All right, part 2, Inference Toolbox, Significance Test for Two Proportions. So, to test a claim about the unknown population parameter. All right, so as I mentioned earlier, first thing we need to do is identify the population of interest and the parameter you want to draw conclusions about. This is where you're going to need to also define what proportion 1 is and what proportion 2 is. So you're going to need to define P1, you're going to define P2. Okay? Your hypothesis again will be P1 is either equal to P2, meaning there is no difference. Your alternative is going to be P1 minus P2. I'm sorry, let me back that up. It's going to either be P1 is not equal to, less than, or greater than P2, depending upon how it is phrased in the problem. All right? Step 2, again, we already talked about this. Choose the appropriate inference procedure. Verify the conditions for using it. Again, simple random sample. The two samples can be viewed as SRSs from the prospective populations, or are the two in a randomized experiment. Normality. The estimated counts of success and failure. Again, you're going to combine your proportions together when you're checking for normality. So you're going to be multiplying them together. Okay? And again, I made a mistake right here. When we multiply those together, they need to be at least 5. I have it correct in the in the next sentence. The two proportion z-test is still accurate as long as these values are at least 5. Okay? And again, notice that we used the combined sample proportion. All right. Continuing down. Again, your calculations. If the conditions are met, carry out the inference procedure. So again, our z will be, okay, p hat 1 minus p hat 2 over the square root of p hat combined times its complement times 1 over the sample size of the first sample plus 1 over the sample size of the second one. Okay? Don't forget to draw your picture. Don't forget, we're going to, again, what I call backloading. We're going to backload the numbers into our formula from the calculator. So as we go through the examples, I'm going to pull the calculator up. We're going to plug the numbers in, and then I'm going to backload those into the z, come up with our p-value, okay? Draw our picture. Interpretation is the same. Interpret the p-value or make a decision about the null hypothesis. And don't forget to use the 3 C's: conclusion, connection, and context. All right, so as we go through this, have the 2 sheets handy. All right, so we're going to go through 2 examples. Example number 1. A study of adverse symptoms in users of over-the-counter pain relief medications assigned subjects at random to 1 or 2 common pain relievers, acetaminophen and ibuprofen. In all, 650 subjects took acetaminophen, and 44 experienced some adverse symptom. Of the 347 subjects who took ibuprofen, 49 had an adverse symptom. We want to assess the evidence that the 2 pain relievers differ in the proportion of people who experience an adverse symptom. All right, so we've got 2 things going on here. We've got 650 who took the acetaminophen, and 44 of them experienced adverse symptoms. We've got 347 who took the ibuprofen, 49 of them had adverse symptoms. And we want to see if the two pain relievers differ. All right, so following the inference toolbox, the first thing we want to do, first thing we want to do is identify the population and parameter of interest. Okay? So, again, as we're going through this, if you wish to pause it, write it down, see if it matches or is pretty close to what I have. Okay? So, first of all, I'm going to define P1 and P2. P1 equals the proportion who take acetaminophen. P2 equals the proportion who take ibuprofen. Next. Okay? The population of interest are all the people who take acetaminophen and all the people who take ibuprofen. Okay, now the hypotheses. So, the hypothesis is that P1 equals P2, meaning there is no difference between acetaminophen and ibuprofen. The alternative is that there is a difference. Again, it didn't say that there was more or less, it just said that they differ, so we have to use not equal to. All right, so step 1 is done. Step 2, we need to identify the conditions, check all of the conditions. Here we go. Simple random sample. Okay, the results came from a comparative randomized experiment. It stated it in the problem. Normality. First, the combined estimate of the overall proportion is, okay, that little c again is telling us, this little c right here is telling us it's combined. So the first thing we need to do is add the successes together, which would be the 44 plus the 49, and add the sample sizes together, 350 plus 347, and come up with our proportion, 0.0933. Okay, so first we need to get that figured out. Now, I have to go through all of the math to verify. So here it is. First, the first sample times the combined proportion, that would be the 650 times the 0.0933, that gives me 60.6. Okay, now I'm taking the second sample size times the combined proportion. So that would be the 347 times the 0.0993, and we get 32.4. Now I'm going to do the complement of both. Okay, and there's the complement of both. So the first one is 589.4, and the second one gives me 314.6. Now, they are all greater than 5. They are all greater than or equal to 5. Things are good. We are safe using the 2-sample Z procedure. Now, what you could have done, again, at any time you could put stuff into the calculator. Okay, in fact, this might not be a bad time to put this stuff into the calculator. All right, so if we go to our calculator, again, go to Stat Test. Now, again, picking out the correct test is essential. If you pick the wrong test, there's no way you can succeed on this. All right, so the correct test would not be number 5 because that's a 1 proportion Z test. It wouldn't have to be number 6, so we pick number 6. All right, now we need to quickly fill in the numbers. So again, the successes for the first one, let me go back, would be 44 and then the sample size was 650. Okay, so 44, 650. Then the next one was 49 and 347. 49 and 347. And you could go ahead and make sure you pick the correct alternative and go down to calculate. And this will give you a bunch of information. This is what I mean by backloading. Okay, you're filling in, you're going to go backwards and fill stuff in. So you have everything here. So you will notice, ladies and gentlemen, if you scroll down, okay, here's P1, P hat 1, here's P hat 2, and here is P hat. Now it doesn't put the little c next to it, but this P hat is the combined amount. And that's what we have right here, 0.0933. Okay, so you could have figured out P hat combined by plugging the numbers in and then look at the P hat. The calculator doesn't put the little c on it. All right, I'm going to stop here and go to the next video because my time is pretty much up for the 10 minutes. So proceed to part 3.